Hey, welcome to SSM Steps Academy, and in today's video we are going to look at the convergence of power series. And here we are given one of the questions that the summation of n equal to 1 to infinity negative 1 raised to power of n. Then we are multiplying by x plus 1 raised to power of n, then divide by 2 raised to power of n. So to find the convergence of the power series and the interval convergence, we are going to use the ratio test, but there are other methods that you can use to find the convergence and the interval convergence of the power series. So in this video, we are going to learn how to find the convergence of the power series using the ratio test. So the ratio test states that when we are given the value an and another value an plus 1, to find the convergence of these two numbers, we are going to take an plus 1, then we divide by an. So in this example we are going to solve, here our an is this question, then our an plus 1 shall be we shall be adding 1 where there is n. So our an here is going to be negative 1 n multiplied by x plus 1 raised to n, then divide by 2 power n. And our an plus 1 is going to be negative 1 raised to n plus 1 into x plus 1 raised to n plus 1 divided by 2 n plus 1. So this is going to determine our ratio test. And our ratio test, we have said that we are going to take an plus 1 divided by an. So proceeding, our an here is going to be negative 1 raised to n plus 1 multiplied by x plus 1 raised to n plus 1 divided by 2n plus 1, then divide by an. And our an is this value, so we are going to multiply by 2 not 2 but so let's erase this, let's erase that one. So it is negative 1, sorry, I have to choose the pen here. So it is negative 1 raised to n, and then multiply by x plus 1 raised to n. So we are multiplying, so we multiply by the so here we multiply by the reciprocal. So the reciprocal is we start by 2n, 2 raised to n. Yeah, so we're having so this is our ratio test, so we can call this ratio test. So solving this, we have to expand the values on the left hand side. So we're having negative 1 raised to n multiplied by 1 raised to 1. So if you have learned about the rules for indices, you know how to find this. So this is negative 1 raised to n multiplied by 1, then multiply by x plus 1 raised to n, then multiply by x plus 1 raised to 1, then we are dividing by 2n multiplied by 2 raised to 1, then of course we are multiplying by 2 power n all over negative 1 raised to n, then multiply by x plus 1 raised to n. So up to this point, we can cancel out some common values like 2 raised to n and 2 raised to n. Then we can also eliminate -1 raised to n and -1 raised to n, and we can also eliminate x plus 1 raised to n and x plus 1 raised to n. So here we shall remain with x plus 1 divided by 2. But now the limit as n approaches infinity, we are getting x plus 1 over 2, but this should be at the absolute value is less than 1. So the rule states that the series converges at C when R is equal to 0 and the C is the center. But the second rule states that there exists a real number R greater than 0 such that the series converges absolutely for x minus c absolute is less than R. So when you're having x minus c absolute is less than R, this is when the series is converging. And if we look at what we have just gotten, we're having x plus 1 dividing by 2 absolute is less than 1. So we have to simplify this equation in the form of x minus c less than R. So here we shall multiply by 2 this side, then by 2 this side, so that we remain with x plus 1 is less than 2. So here we shall get c as so here we shall write x minus c is less than R. Then this 2 is our R and 1 is our c. But as you can see, our c is negative, so the c is equals to -1. C is equal to -1, while R is going to be -2. So the interval convergence is going to be so up to here we're just having C and -1 and R as not -1 but 2.